Hello students, today we will discuss the fourth application of derivatives, and the fourth application of derivatives is to find the approximation. Approximation means to find the approximate value of some given number, and if I take some simple example, let us see, we have to find the approximate value of 25.2. Okay, now we know the exact value of root of 25. What is that? 5. But this point 2 is the change or increment, right? So corresponding to this small change in the value of x, what will be the total change in the value of this number? This we will learn with the help of derivatives, and it is the fourth property or application of derivatives, that is called approximations. So let us make a formula. We will understand the concept, what is the concept of this, and here we will be using our first principle of derivative also. With the help of first principle of derivative, we will make the formula. If you remember, what was the first principle? If I have y equals to f of x function and there is small change, we will say let delta x, or you can use this symbol also, be the small change, or small increment, we can say small increment in x, right? Then let del y or delta y be the corresponding increase in y, because as x increases or decreases, this y will correspondingly increase or decrease, because x is independent variable and this y is a dependent variable. So when there is a small increment in the value of x, there will be small change in the value of y also, right? And we denote, and if I have to find the change only, if I know I want to find del y only, that what is the change in the value of dependent variable, then what I will do, if I mark it as 1 and this I mark 2, then I will simply do 2 minus 1, so it will become f of x plus del x minus f of x. It's all come under the your first principle of derivative, right? And here, what is this del x? We are saying del x is the small increment in x. Okay, so this del x, that is the small increment in x or small change in x, right, is actually can be taken as dx also, right? So this is important thing. Since x is a independent variable, so the change in x, del x, this is the change in x, is actually directly can be considered as differential of x. So small change in x, del x, is equal to differential of x also. Because if you remember in the derivative part also, when we write down dy by dx, what does it mean? Change in y, where y is the dependent variable, when we write down dy by dx, it is rate of change of y with respect to change in x, and this dx is representing the change in x. So this dx is change in x also, and it is also called differential of x, right? And when I take here this del y, change with respect to x, del x, and I take this limit, this del x approaches to 0, then it becomes change in y corresponding to change in x. Okay, so the differential of dependent variable is not straightforward dy, but the differential of dependent variable dy we will get from this. Okay, what does it mean? And if I say dy by dx, now the dy by dx is actually nothing else but it is the rate of change of y with respect to change in x. So when there is change in x, that change in x is directly called differential of x. But corresponding to this change in x, whatever change is happening in y, that is differential of y, I cannot say it is directly equal to del y, because it is happening due to some change in the independent variable. So change in the independent variable when occurs, and if I take that change is very small, almost negligible, then this del y upon del x, when del x is approaching to 0, is actually dy by dx. Okay, and this del y by del x, when we take and this del y by del x, it means I can take as dy by dx. It can be approximate, not exactly, but it will be approximate. And from here I can say the differential of y will be equals to then dy by dx into del x, right? Differential of y. Now this is differential of y. Ultimately we are getting the value of differential of y. So what is differential of y? It is the change in y with respect to x into, or I can say the derivative of y with respect to x into the corresponding change in x directly, that is differential of x. So this dy by dx, what was the y we have taken? Y is actually fx. So we can say that del y will be equal to f dash x into del x. So this is the change in the dependent variable y corresponding to the change in independent variable x. If I have to find only change in x, it is del x, whatever change is there, that is del x or dx. But corresponding to this change, what is the change in y, that is dependent variable? Okay, we have calculated that del y will be equals to f dash x into del x, right? Okay, now this del y, if I substitute here, what was this second equation? The first equation was the function as such, but in the second equation we have said that when there is change in x, what is the new value of y? Because as x changes, what is the new value of y? That is y plus del y equals to f of x plus del x, right? So it means we can write it as y plus del y is equal to, the value of del y is y plus, what was the value of del y? F dash x into del x, right? F dash x into del x. And what was y? And what is this y plus del y? I am going to make the formula. Let me show you here in the beginning. What was y? F of x. Y plus del y, f of x plus delta x, right? That means the function, the change in function here. And what was the del y calculated? F dash x into del x, right? So all these values, if we substitute here, what we will get? Y plus del y. What was y plus del y? It was f of x plus del x. And what is this y? Y is f of x. And this thing already we have substituted, f dash x into del x. So this formula, f of x plus del x is equals to fx plus f dash x del x, formula we are going to use in the exercise, right? We have just calculated the value of del y that value we have substituted here, and the value of del y is dy by dx into del x, and dy by dx is nothing else but it is f dash x. Okay, so this is our formula that we will use in the exercise. In place of this del x, you can write down the other form also, f of x plus delta x. It also represents the small change only, f of x the function plus f dash x into change. The formula is done. Now the question is, how will we do it? How will we implement the formula? Let us do it. I will take the first sum of the exercise 6.4 here. The first sum is, the statement says, using differential find the approximate value of each of the following up to 3 decimal places, and the first is root of 25.3. Here we have to note two things. First of all, what is the function here? What is the function here? Function is a square root function, right? And inside the square root function, what is the value given? 25.3. 25 is the number for which I know root 25, we know it is 20, it is 5. So that we will take it as x. What is the change in x corresponding to which the whole value we have to find? It is 0.3, right? So first of all, this I will write down as 25 plus 0.3. Right? Now this 25 is actually x, and this is our change, delta x. And remember, this delta x should be very, very small as compared to x. It cannot be very close to x, it cannot be more than x, because it is the small change in x, and small change means should be small only, right? So this thing is done. Okay, now we will write down what is the function here. What kind of function we have? It is the square root function. That means when x is there, I have here root x, right? And what is this? This is actually, we have, or when I say x plus delta x, it is f of x plus delta x. So this f of x plus delta x we are supposed to find. So what is here f of x plus delta x? This is f of x plus delta x, for which we have to find the value, and this we will write first of all f of x, then f dash x. That means we will find the derivative also, into change also we will write down. What is the change here? Delta x. The change directly you will take 0.3. It is not root, it is only 0.3, because you are not talking about f of delta x, it is only delta x, right? So this thing I have written just to explain to you people. There is no need to write down. So if f of x is delta x, right, let us write down what is the value of delta x. Delta x is 0.3, and what is the value of x? That also let us write down. It is 25. F of x is done. Now f dash x. We know what will be the derivative of f of x. It will be 1 by 2 root x. I hope everybody now knows how to find the derivative of root x, right? When we differentiate, root x means x raised to power 1 by 2. So power in front, reduce the power by 1. It will become minus 1 by 2 into derivative of x is 1. So it will become ultimately 1 by 2, and this root minus is, so it will come to the denominator, right? I hope the step is clear. F dash x is calculated, fx is written, fx is, we know f dash x is already calculated, del x also we have written 0.3, and what is the value of x? That we should know. X is here 25, right? We will write down, therefore root of 25.3 is equal to f of x plus f dash x into delta x. What is the value of f of x? That is root 25 plus 1 by 2 root 25, because f dash x, what is the value of f dash x? 1 by 2 root x. So wherever x is there, we will substitute the value of x as 25 into delta x, that is 0.3. So it is 5 plus 1 by 2 into 5, and here you have 0.3. So it is 5 plus 1 by 10, 0.3 is there, and if you take 0.3 divided by 10, one more decimal will be there. So the final answer, let us write down here itself, it will become 5.03. One more decimal point will increase, place will increase, so the answer will be 5.03. This is how we will do the sums. Okay, this is the first sum of the exercise, and whatever sum value is given, we have to write it as f of whatever function is given, x plus del x. We should know the value of x and we should know the value of delta x. Okay, let us do one more sum. First sum already done, second sum, third sum, same function is there, square root. So let us do here fourth part. The fourth part says we have to find the approximate value of 0.009, power is 1 by 3. That means it's cube root now, right? The value is here cube root. So let us find, first of all, the nature. It is cube root function. So we will write down here f of x is x raised to power 1 by 3. Okay, we will mention it. Now cube root, we have to check for which nearest number to this 0.009 we know the cube root. Okay, if you 0.009, or if you only look at 9, we don't know the cube root of 9. Okay, go to 10, we don't know the cube root of 10. Go to 8, we know the cube root of 8. What is that? 2. It means this 0.009 can be written as 0.008 plus 0.001 whole power is 1 by 3. Because I know the cube root of this number, so this will be taken as x, and this second part will be taken as del x. Remember, this del x should be very, very small as compared to x, and it is. Okay, so function is x raised to power 1 by 3. We know the value of x, we know the value of del x also. So the next thing we will find here the derivative. What will be the derivative? Power in front, reduce the power by 1. 1 by 3 minus 1 is minus 2 by 3. Okay, into derivative of x, that is 1 only. Okay, therefore f of x plus del x is equal to f of x plus f dash x into del x. That's it. If I know the value of x, I know del x, I know the derivative, I know fx, the sum is done. So it implies 0.009 raised to power 1 by 3 is equals to, what is f of x? It is 0.008 raised to power 1 by 3 plus f dash x is also calculated, 1 by 3 into x raised to power 2 by 3 into del x. What is del x here? 0.001. Let us use multiplication sign. Okay, so this is actually cube root of 0.008. What will be that? 0.2. I hope it is clear to all. It will be 2 by 10 into 2 by 10 into 2 by 10, actually raised to power 1 by 3 है ना. So 3 zeros, 3 place, 8 by 1000, so 0.008. Okay, plus 1 by 3 will come as such. Similarly here in place of x, okay, here also we were supposed to put the value of x only. It's okay if I forgot to do there. Let us rewrite the step, perfectly fine. So here it is 0.2 plus this is 1 by 3 into once again 0.008 2 by 3. If this 2 I don't write 1 by 3, it will be 0.2, and 0.2 square, what will be 0.2 square? We will be left with 0.2 square, okay, and here 0.001, so it will be 0.2 plus 0.001 divided by, it will come 0.04, okay, so 3 into 0.04, and rest of the calculation you people can do and you will get your answer here. My motive is to make you understand the concept here. I am repeating, whatever number is given, first of all we will check what is the nature of the function, means what type of function is given. Here it is some number raised to power 1 by 3, and if this number I replace by x, I am getting the function x raised to power 1 by 3. Then we will write down the number in such a way for which I know if the nature is function is cube root function, I will find is this number or do I know the cube root of this number. If I know, it's okay. Otherwise we will divide it or we will break it in these two parts for which I know the cube root of x, and this del x will be the change in x or increment in x, corresponding to which we will find the change in the whole value, okay. Similarly you people can do the remaining parts, or you people can do the full first sum of this exercise 6.4. The first sum is having 15 parts. Only this formula, that is f of x plus delta x, you people have to use everywhere, right? And for this you should know fx function, the derivative of that, and the change, what is the change here, del x, you should know. These three things if you know, substitute here, rest of the thing is calculation only. You do the calculation and you will get your answer, right? Let me tell you one more here, some exercise 6.4 only, the 15th part. 15th part is here, we have to find 32.15, power is 1 by 5. So fifth root of 32.1 by 5, that means if I just replace it by x, so I will get what is f of x. F of x then will be x raised to power 1 by 5. Now for which term here 32.5, you know the value for which it is 1 by 5 power is. If you know 2 raised to power 5 is 32, it means 32 raised to power 1 by 5 will give you 2, right? See, you will get it very easily because we have done all the cube roots, powers, exponents we know. So that's not a big deal that you have to work hard on finding the numbers. So it means this number we can write it as 32 plus 0.15 whole power 1 by 5. So this will become x, and this is our increment del x, and f dash x you can calculate, it will be 1 by 5 into x raised to power 1 by 5 minus 1 will be minus 4 by 5, so that 4 by 5 will come in the denominator, right? Therefore f of x plus del x will be equals to f of x plus f dash x into del x. What is f of x? It is x raised to power 1 by 5, f dash x 1 by 5 x power 4 by 5 into del x. Let us substitute the values. So the answer of 32.1 by 15 will be here. In place of x it is 32 raised to power 1 by 5. We know it will be 2 plus 1 by 5 into 32 raised to power 4 by 5. And what is del x? It is 0.15. Okay, so here we will get 2 plus 1 upon 5. If this will be, if you want, we can write down 2 raised to power 5 into 4 by 5, and here we have 0.15. Okay, so 2 plus 1 upon 5 into 5 and 5 will get cancelled. 2 raised to power 4 will be 16, and here you have 0.15. Okay, so I think the sum is done. When you solve it, you are getting your answer. So you will find the exercise easy, very easy as compared to the other parts where so many things you people were doing. So you people can complete this exercise 6.4. First, sum 15 parts. The second part of the exercise we will discuss in the next class. Thank you, students.